Okay. Hello everyone. I'm Weicong and I'm a master student from Gaolin School of Artificial Intelligence, Renmin University of China, and I'm delighted to be here sharing our work with you. The title of our paper is Explicitly Integrating Judgment Prediction with Legal Document Retrieval, a law-guided generative approach. And first of all, I'll give the background of the two tasks mentioned in the title. So, legal document retrieval is a search process tailored to the domain of law, aimed at identifying and searching precedents, documents, or statutory articles pertinent to a given query. Its objective lies in assisting legal practitioners in comprehending precedents handling methodologies and the precise meaning of legal provisions, thereby facilitating analysis of potential legal reasons. The figure on the right shows an example of a query candidate peer in this task. Given the query case documents, our goal is to retrieve relevant documents like the one on the right. The red and blue text indicate their corresponding parts. On the other hand, legal judgment prediction employs technologies such as artificial intelligence to forecast the judgment results of the query based on historical decision data. This task analyzes case facts, applicable law, and other multidimensional information. The figure on the right also shows an example of this task. Given the query document, our goal is to predict the charges caused by the facts of the query case. And the red and blue text are associated with the judgment. So these two tasks are closely related and complementary to each other. From the retrieval perspective, determining whether the two documents have the same judgment or similar judgment is crucial for us to establish their relevance. The figure on the right shows an example. The predicted judgment results can help us better find the relevant case documents. And on the other hand, from the judgment perspective, using information from retrieved similar documents can enhance the accuracy and the reliability of the judgment prediction. As shown in the example on the right, relevant case documents can help us better predict the judgment results. So, in our opinion, integrating these two legal tasks enables the model to better understanding the legal text and judgment logic by simultaneously learning how to retrieve the similar documents and how to predict the judgments. The model can more comprehensively grasp the legal knowledge and judgment rules, leading to more reasonable or reliable predictions. Recent words are aware of this kind of relationship. They try to enhance one task with the feature of the other, but they primarily focus on one or the task. And this stems from three challenges in our opinion. The first and the biggest challenge is that the two tasks are usually formulated as two distinct machine learning problems with different task formats. And secondly, legal documents are inherently lengthy and complicated. It results in the retrieval efficiency issue and hinder to observe the shared representation for both tasks. And thirdly, both tasks rely on specialized law knowledge and an appropriate way that effectively injects law expertise to guide the prediction for both tasks remain a concern. And Next, I will introduce our motivation, that is to integrate them with a tool. So what is the tool? Traditional retrieval is unable to address the challenge we face, but the recent retrieval paradigm, generative retrieval (GR), has inspired us. Diverging from generative retrieval approaches, this kind of technology leverage LM to auto-regressively generate document ID for retrieval. We can view the inference of each step of the ID token as a step of classification. That is, many steps of the token classification make up one step of ID retrieval. Therefore, generative retrieval naturally becomes our tool for integrating these two tasks. On the other hand, we know that generative retrieval is based on a search space, that is the search tree of generative retrieval. In order to address the challenge 2 and challenge 3 and to introduce judgment knowledge into the retrieval process, we introduce the SIGIR law, that is the legal code of the SIGIR principle and rules, to be the guideline for both tasks. And this kind of law has rigorous structural information, and it can be used to build a constraint tree as a search tree of generative retrieval. So our idea is to use the structured information of law to construct a structured tree and initialize generative retrieval search tree. Know that each level represents the specific level of the law. So the process of generating an ID includes the prediction of judgment tokens. In this way, we achieve the integration of the two legal tasks. Next, I will introduce the method we propose, which is called SIGIR. And we use generative retrieval as the backbone, as I just mentioned. And then we use legal structure tree of the law to be the constraint tree of the search space. Specifically, this simultaneously assigns each candidate document an ID identified with judgment level semantic token. Furthermore, each retrieved document can reveal its reasoning process path via the corresponding ID, which can be traced back within the structured framework of the law for explanation or interpretation. In order to obtain the SIGIR text representation, we propose rationale extraction. It extracts key text in the input based on the law. Specifically, it evaluates and selects keywords and sentences from the inputs based on the multi-level knowledge corpus. This kind of corpus originates from the law, and we expand it with additional legal documents and legal large language model, forming a multi-level corpus. By doing this, we are able to quickly locate legal-related keywords and sentences from the input documents and query to address the efficiency issue. For the last design, to consistently and jointly optimize the two tasks, we introduced revision loss for generative retrieval. It reduces the error between the predicted ID and the label ID by applying hierarchical and rank penalties. Please note that this hierarchy here is aligned with the law structure tree. By doing so, we force the model to optimize the generated results in the structure tree and improve the retrieval quality. Next, I will present our experiment. We conduct experiments on 3 datasets. 2 of them are Chinese dataset and 1 is French dataset. As for the retrieval performance, we use recall and MRR metrics to verify the judgment prediction ability. We introduce a new metric, coverage at K. It assesses the percentage of charges involved in the query that can covered by the top K retrieved documents to evaluate the judgment prediction performance of generative retrieval. As for retrieval performance, we can say that our approach outperforms traditional retrieval methods, dense retrieval, and other generative retrieval methods. We also conduct a ablation study removing three modules from GEAR and observe a decrease in performance. Additionally, we add each of them to a baseline DSI and separately and find improvements. It demonstrates that each component of GEAR is effective. Furthermore, we also examined the consistency between predicted judgment of retrieved documents and the query charge judgments, finding that the charges of retrieved documents show high coverage of the query charges, indicating that GEAR is competitive, capable in predicting judgments. Additionally, we conduct efficiency experiments and find GEAR excels in efficiency compared to other generative methods. Lastly, we validate GEAR's cross-lingual robustness on the French statutory article retrieval dataset result, and the performance also shows its cross-lingual robustness. And finally, I will provide a summary. In conclusion, our motivation is based on the need to integrate the two related yet distinct legal tasks to improve the legal decision-making process. Faced with the challenge-like different formats, shared representations, and guidelines, we propose our method here to use generative retrieval to address them and integrate the two tasks. It constructs a legal structure tree to assign identifiers, embedding legal structure and judgment information for more accurate predictions. GEAR achieves dual prediction in a single inference, showing strong performance in legal document retrieval and judgment prediction with a cross-lingual robustness.